Welcome to the next video of Chapter 7. This is a continuation of operations on functions. As you can see at the top, what we're going to be talking about today is called a composition of functions. Now, before we do that, we're going to do a little bit of a review. So let's jump into example number 1. Let f of x equals 2x and g of x equals x plus 1. Find the following. Okay, so we're reviewing some function notation. So part A asks us to find f of negative 3. Here's what that notation tells us. We are plugging in negative 3 for x into function f. So function f is this 2x. So 2, I'm replacing x by negative 3. So I get an answer of negative 6. Similar notation or similar idea in part B. Part B is telling us in place of x, we're putting a 6, and we are using function g. So here's our function g. In place of x, I'm putting a 6. So I get a final answer of 7. Those we've seen before. C and D is something new, but hopefully we can figure it out. So we have f of g of 2. What I'm going to ask us to do first is just focus on this g of 2 part. So g of 2. Ignoring the f, we can find that. We can find g of 2. We're plugging in 2 for x. So we get 2 plus 1, which gives us a 3. Okay, so what this is telling us is that g of 2 is equal to 3. So in my notation then, where it has g of 2, I can plug a 3 in. So rather than f of g of 2, g of 2 is equal to 3. I'm finding f of 3. Okay, that I've done before. Again, I'm using function f, but I'm plugging in a 3 for x. So I get a final answer of 6. Okay, we're going to try that again in D. So in D, I'm focusing on the middle. I'm going to find f of negative 1. So I'm plugging in a negative 1 for x into the function f. So I get 2 times x though is negative 1. So I get a negative 2. So again, same idea. F of negative 1 is equal to negative 2. So this f of negative 1, I'm going to replace with negative 2. So g of f of negative 1. So like we said, f of negative 1 is just negative 2. So really, that's the same as finding g of negative 2. If I plug negative 2 in for x into function g, I end up with an answer of negative 1. Okay, what we did in C and D, that's what a composition of functions is. So let's take a look moving further down into our notes. When you evaluate one function, then use that answer to evaluate a second function, you are performing a composition of functions. Okay, before we look at another example, we need to talk about some notation. There is a bunch of different ways that you're going to see a composition. You could see f of g of x. What that's saying is plug g into f. Another way to write that is like this. So those have the same meaning. We are going to substitute g of x into f of x. Now what I want you to notice is that circle in the middle is open. It's not a closed circle. We've seen the closed circle before. The closed circle is multiplication. So the open circle is a composition. We could also do g of f of x. So that notation is telling us plug f into g. Plug f into g. And again, another way to write that is g of f of x. So again, that second notation is telling us that we are going to substitute f of x into g of x. Okay, I think we need to look at an example together. So we're going to do an example together, and then you're going to do one on your own. So flip to the next page, please. Okay, example number 2. Let f of x equal 2x minus 3 and g of x equal 3x plus 4. Find the following and simplify completely. Okay, so part A, this is the notation that's new. I'm going to rewrite this. This is the same as f of g of x. What is that telling us? It's telling us we're taking g and substituting it into f. We're taking g and substituting it into f. So here is our g. That's going to go in place of x. So we have 2. Instead of x, though, we're replacing it with 3x plus 4 minus 3. So we're going to simplify. Distributing that 2, we get 6x add 8 minus 3. Final answer being 6x add 5. One thing I want to point out to us, we were asked for f of g of x. What that tells us is there should be an x in our answer. Our answer should be in terms of x. Okay, so then in part B, if we write this again, this is g of f of x. So I'm going to do this one in green. We are taking f and plugging it into g. So we're taking all of f, putting it in place of x. So for g, we have 3 times x. Instead of x, though, we're replacing that with 2x minus 3, and then plus 4. Distributing that 3, we get 6x minus 9. And then we get 6x minus 5. Again, reminding us, we were asked for g of f of x, which means our answer needs to have an x in it. There's another type of problem that you could see. You could be asked for something like this. This is completely different than, not completely, but it's different than what we've seen in A and B. Since there's a number here, our answer should be a number. Now, we have a few different ways we can go about this one. First way is we know f of g of x. F of g of x we found. So what we could do is we could just plug 2 in. So we could do 6 times 2, add 5. So 12 add 5 is equal to 17. That's one option if we already have f of g of x. Or f of g of 2 is the same as f of g of 2. So we could find g of 2 and plug it into f. So let's do that real quick. G of 2, we get 3 times 2, add 4. So this is 6 add 4, which is 10. That 10 then goes into f. So we get 2 times 10 minus 3. 20 minus 3 gives us a 17. And that shouldn't be a shock. We already knew from up above in yellow we were going to get 17. So what I wanted you to show here, or what I wanted to show you here, is it's very important if there's an x or a number. If we're taking f of g of x, our answer will be in terms of x. If we have f of g of a number, our answer will be in terms of a number. Okay, you all have an example to try on your own. I'm going to help you out with this example 3. Okay, in part A, we are finding f of g of x. So our g of x is going into f. G of x is going into f in place of x, which you can see it's going to be in 2 places. So we have x squared, but instead of x, we're replacing it with 2x minus 4. Minus 3, we're replacing that x with 2x minus 4 plus 2. Okay, and then you need to simplify that. Please be very careful here. This is one that we tend to mess up. So I would suggest you do that over to the side. Remember that 2x minus 4 is 2x minus 4 times 2x minus 4. Okay, and then you'll finish that one. In part B, this is g of f of x. So in this case, f is going into g. If you need a review, you might need to, or if you need a little help, you might want to go back and rewatch example 2. When you come to class and turn these notes in, I will expect both of these problems to be done. Good luck!